Okay, this is classwork video 12.1. Copy down all this work onto the handouts I'm giving you, and then write down the 5 words to show me that you're listening, and then listen for instructions. All right, so here we go. This first one, I give you the fact that it's $0 after 0 times, $0 after using it 0 times, $0 you're paying right off the bat. That means this is going to be a proportional situation going through the very middle of the graph, that very corner. So looking at the change in my C numbers, that is my rate of change. That is my slope number. That's the number that goes in front of X, or for T for this situation, which is number of times. So if I write this equation, it's going to be the cost of using this pull situation is $5 each time, and then plus that $0 you're spending at the beginning. It's free. Of course, the $0 is free access maybe. So that would be C equals 5T. And looking at that equation, you're going to need to know, even if that's not a Y, even if that's a C and a T, or an X and a Y, any equation without a y-intercept number is going to be going through the middle of that graph. It's going to be what we call proportional. It's going to grow proportionally. I know that because it's going through the corner. It has no y-intercept. I could use that equation to calculate the cost. Remember, this is cost. This is time. I could calculate the cost after using it 20 times. So the cost of using this pull 20 times is 5 times 20, and then that gives me $100 to use this pull after using it 20 times. First word is red. All right, I need you to know how to graph. This graph, the way this is set up today, each number on the t-axis is going up by ones. That's your x-axis right here. And then all my other numbers, my y-axis, that's going to be going up by twos. Going up by twos on this y-axis. Hopefully you could see that going up by twos. That's going to be my cost. Cost is going to be like y right there. All right, so if I plot them, that first point, 0, 0, pretty easy. That next one, though, is really going over 1 for T, up 5 for C. So if I'm going up boxes here, that's about 2.5. That would be right about here. That's going up 5 on the scale. Going over 2, I go up to a clear box 10. Going over 3, I go up another 2.5 boxes exactly. That's 5 on this graph. Going over 4 up to a square grid 20. Draw a line through those, straight line. All these graphs are going to be a straight line, never not a straight line, because they always are going up by the same amount each time, going up by 5. That's my graph. And then what you need to know are these things right here. That y-intercept for this one right here, that point right there, is 0, 0. You need to know what that means. That means after using this pull 0 times, it cost $0. You need to write that. Using pull 0 times cost you $0, and maybe I'll put a 0 right there. It cost you $0. That's what that point means. It's not just nothing. 0, 0 is the origin, means after using the pull 0 times, you spent $0. That's what that means. And then, of course, everything else on the graph, these are growing proportional. Look, going over 1, going up 5. That's my rate of change. That's my slope number right here. That matches the same proportion going over 2, up 10. If I divide that, that's another 5, which is proportional to 3 going up 15. That's a slope of 5, which is proportional to going over 4 up 20. Make sure you're showing this on your paper for full credit. Write all of this for full credit. That's what a proportional graph does. It grows proportionally. All those proportions are equal. They're equal to 5. Next word is blue. Blue. All right, here we go. 2 more. This one. I give you a y-intercept. This is saying that you're spending $12 for using the pool 0 times. $12 right away. That means it's not proportional. It's not going to go through the origin. It's going to be cutting through higher on the graph. It's not proportional. So here we go. Looking at that, $4 each time. That's my slope. That's my rate of change. That's how much I'm spending each time I use it once. One time using the pool cost me $4. That's what this is saying. So my equation is the cost of using this pool situation is $4 each time, but I gotta account for that $12 fee I spent at the very beginning. Always gotta calculate that into the calculations. So to figure out the cost after 10 times, I plug in 10 for that T right here, and that will give me the cost using this 10 times. Using this pool 10 times will cost me 4 times 10, 40, plus 12. It will cost me $52 to use this pool 10 times. That's what that means. And then graph it. Here I go. 0, 12 is right here on my y-axis, not going through the origin. That's 0, 12. 0 times already cost me 12 bucks. 1 time cost me 16. 12 would be right here. 2 times cost me 20. 3 times cost me 24. Look, going up the same amount, over 1 up 2. Going over 1 up 2 on this graph, which is 4. Draw your line. Make sure you have arrows at the end of that line always. They're really nitpicky about that. And then for this one, I want you to look at this point right here and write this. That's 3, 24. What does that mean? That means using the pool 3 times cost you $24. You need to know that. Using pool, write this, 3 times cost Joe $24. That's what that point means. That's what that point is telling someone looking at this graph. And then of course this graph, looking at it, tells me this 0 point right here means at 0 times I spent $10, and then tells me that each time I go over 1, I'm going up not just 2 right there, because this graph, each box is 2. So that really, when I'm going up, that's 4 right there. And then you can see that triangle is not they're not proportional. They don't grow proportionally. All right. Last problem. Next word is tan. Tan. All right, this one where you're going to have to backtrack and fill in the table. $14 one time, $20 using it 2 times. That means you could figure out everything. You could figure out that it's going up by 6. Hopefully you could see that. So my next values would be 26 right here. And then going up 6 more will give me 32. And going up 6 more would give me 40. That's what that's telling me. Going up by 6. 14 to 20 is going up by 6. So if I keep adding by 6, that will give me the other numbers in this C column, cost column. Keep adding by 6s. All right, this equation, here we go. The cost for this pool situation is, I gotta backtrack on this one. I can't use 14 right there. That's not my y-intercept. So for this one, backtrack to 0 times. I take that 14 and I take away 6. Again, gotta be able to do this. 14 minus 6 gives me $8. So using that shows me that using the pool 0 times cost me $8. That's your $8 fee that you're paying right away before you've used the pool any time here. So if I write my equation, the cost to use this pool is that same $6 each time plus that $8 entry fee or yearly fee that I got by backtracking on this data. And then I could use that to find out the cost at 10. Plug in 10 right there. Gives me 60 plus 8. Gives me $68 that it cost if you're using the pool 10 times. And then of course, all of these points, if you want to prove, will work. If I plug in 3 right there, that gives me 6 times 3. Is that going to give me 26? Let's see. 18 plus 8. Yep, that does give me 26. You can see each time you plug in one of those T numbers, it spits out that cost. That's why your equation's clutch. And then graphing it, second to last word is black. Black. Graphing it, here I go. 0, 8 would be right here using this graph going up by 2's. Going 1 time goes up to 14. Twice using it, $20. 3 times, $26. You can see that pattern going over 1 box up 3, 1 box up 3. Be able to stair step opposite way too. Draw your line through them. And then just one more thing you got to know. Let's take a look at this point right here. What's going on right there, folks? That's the point 220, which means using this pool 2 times cost you $20. Write that. Using the pool 2 times costs $20. You need to know that. All right. Hopefully this all makes sense. Got to know this. Bring it to the tutor. What I'm going to have you do today with your row, I'm going to give you a blank one of these and fill in the numbers for you. Come by, fill in the numbers, and then have you do it as a row, and we're going to have you present those to the class today as part of what we're doing. All right, next word is green. Green. Good luck.